Okay, so temperature changes and heat capacity. We have a term called heat capacity, and that means the amount of heat needed to change the temperature of something. Some substances change temperature very easily, and others do not. It takes a lot of energy for the temperature to change. And you can see this in your dinner plate. You're served a plate of food, and it's all just piping hot. But some of it cools down a lot faster than others, and some of it stays hot seemingly forever. That baked potato is going to take forever to cool off, right? But if you have a piece of toast, it gets cold very quickly. Different substances heat up and cool off with more or less energy than others, and heat capacity is what measures that. It's usually measured in joules or calories per gram degree Celsius. And when we use it with the grams, then we call it specific heat or specific heat capacity. So here's a table showing specific heat capacities of several substances. And if you look at that, notice that water has a specific heat capacity of 4 compared to these other things. Water, you have to put a lot of energy in it to heat it up, and as it cools down, it releases a lot of energy. Unlike metal will heat up very quickly and cool down very quickly. So you may need to use a table like this when you're doing homework problems. You do not need to memorize heat capacities, though. If you need them on an exam, they will be provided in some way. So we have an equation that helps us to relate heat, which is energy, relating it to the mass, the specific heat capacity, and the temperature change. And if we just step back and think about this equation and think about, well, how much heat is given off by boiling water? Say you got some boiling water on your hand, and it was boiling at 100 degrees Celsius, and it cools down to your body temperature at 37 degrees Celsius. It's going to release energy into your hand. That's why it hurts when you get boiling water on you, because all this energy comes into your hand and it's painful. We see that if the temperature change is greater, if it's 100 degrees going down to 37, which is body temperature, or if it was, like 40 degrees Celsius going down to 37, the hotter the water, the more painful it is, the more heat comes out of it. Does that make sense? Okay? And it also depends on the amount of water. If you get a drop of boiling water on your hand, you're like, ouch, but it's no big deal. If you had a cup of boiling water spilled on your hand, you're going to be in trouble, right? You're going to get a burn. More water, more substance, same temperature change is going to release more heat. So the amount of heat released or taken in depends on the mass, the amount of the substance. It depends on its specific heat capacity, and it also depends on the temperature change. The temperature change is given there as delta T. Delta is a Greek letter D, and it stands for change. So delta T means the change in temperature, and that always is the final minus the initial. So the change in temperature is the final temperature minus the initial temperature. So here's an example, but I don't think we have time to do this. So we're not quite finishing Chapter 3 today, which means that I will extend the deadline on the Chapter 3 homework. Okay? Because the Chapter 3 homework can't be due until after we finish Chapter 3. Even if I forget to extend it, I will extend it eventually, and when I do that, it retroactively gives you all the points back. So don't stress about that. Okay?